Have you ever wondered how a program, actually remembers your name or how it keeps score in a game? Well, it all boils down to three core ideas: variables, scope, and data types. If you can get these down, you're on your way to understanding the fundamental building blocks of pretty much all code.
So here's our game plan. First up, we're going to tackle the main building block, the variable. Then, we'll figure out the rules of where you can use them, that's scope. After that, we'll look at all the different flavors of info you can put inside those blocks, see it all come together, and finally, we'll talk about why getting this right is just so crucial for writing solid code.
Okay, let's dive right in. We're starting with the most essential concept, the absolute heart of programming, the variable. So what in the world is a variable? The name might sound a little bit technical, but I promise you the idea behind it is something you already use every single day.
Honestly, it's super simple. A variable is just a container for a piece of information. The best way to think about it, it's just a box. You put something inside the box, and you slap a label on it so you can find it later. That's it. That's a variable.
Let's make this real. See here? We've got three boxes. One is labeled name, and inside, it's holding the word Alice. The next box, labeled age, is holding the number 16. And the last one, height, has 1.68 inside. See? It's just a label pointing to a piece of data.
Okay, so we've got our boxes, but can we just grab any box from anywhere we want? Well, not exactly. And that brings us to this really important idea called scope. Think of it as the rules of the road for where your variables can be seen and used. Scope really boils down to two main flavors. You've got your global variables, which are kind of like a giant billboard. Everyone in the entire program can see and use them. And then you have local variables. They're more like a secret whispered in a meeting. They only exist in one specific, small part of your code.
Check this out. The school name variable is created way up at the top, outside of any specific function. That makes it global. And because it's just out there in the open, the showInfo function can easily look up and use its value. It's public knowledge available to everyone.
Now for the total opposite. Here, the student name variable is born inside the student data function. It's local. That means it lives and dies right there in that little block of code. So if you try to ask for it from the outside, your program is going to throw an error. It's basically saying, student name, never heard of it. All right, time for a classic little programmer's puzzle that really shows why scope is so important. We have a global variable, x, and we set it to 10. But then, inside this calculate function, we create a totally different local variable that just so happens to also be named x, and we set that one to 5. So, here's the million-dollar question. If we run that function, what is it going to print? And what about when we check the value of x outside the function? Does the inside one change the outside one? What do you think?
And the answer is, they're completely separate. Inside the function, the program sees the local x and prints 5. But as soon as that function is done, the local x just, poof, disappears. So when we check again from the outside, we're back to seeing the original global x, which is still 10. The local variable just temporarily hides the global one. It never actually touches it.
Okay, so we know what variables are, and we know about their neighborhood rules or scope. But what can we actually put inside our boxes? This is where our third big idea, data types, comes into play. You see, computers need to know what kind of information they're dealing with. Is it a simple true or false, a yes or no? That's a Boolean. Is it a whole number, like 5 or 100? That's an integer. What about a number with a decimal point, like 3.14? That's a float. And for any kind of text, you've got characters for single letters and strings for words or sentences. All right, the theory is great and all, but let's see how these pieces, our variables, their scope, and their data types, actually fit together and work in real code.
Here we go. We've got a Boolean variable called isLoggedIn, and we flipped it switch to true. The program then checks that switch. Since it's on, it goes ahead and prints access granted. It's a simple on-off switch that can control what your program does next. And this is why the type is so important. Your score on a test might be a nice whole number, an integer like 88. But if you're calculating something precise like your overall percentage, you need a float like 88.5. If you used an integer there, you'd lose all that decimal information and get an inaccurate result.
Here, we've stored the string Maya in the name variable. Now, strings are cool because they're basically a lineup of characters, all in a specific order. And because of that, we can easily grab just one piece. Here, name 0 grabs the very first character in the line, the M, and stores it in our initial variable. This is a fantastic example of scope working perfectly. We have our global balance of 1,000. The deposit function can see that global value, so it reads it, adds the new amount, and then stores the final result in its own private local variable called new balance. And here's the crucial part. The original global balance is never changed. This is a really safe and clean way to work with your data.
So we've covered a lot of ground here. Variables, scope, data types, but why is it so important to get this stuff right? Let's zoom out and look at the big picture.
Okay, let's boil it all down. Variables are how you store and manage information, period. Understanding scope, knowing the difference between global and local, is what keeps your code organized and prevents one part from accidentally messing up another. Choosing the right data type makes sure your code runs efficiently and, more importantly, correctly. Getting all this right is your absolute best defense against creating messy, buggy code.
And if all that still feels a little abstract, think about it like this. A global variable is like your school's official name. Everybody on campus knows it. A local variable is like your name written on a single pop quiz. It's only relevant in that one specific context. An integer is for counting students. A float is for measuring someone's exact height. And a Boolean is your attendance. You're either here or you're not.
So, I'll leave you with this thought. You now have the keys to how a program thinks and remembers. If you could build anything at all, what is the very first piece of information you would teach your program to store? Now that you have the building blocks, the possibilities are literally endless.